We're going to talk about states of matter, solids, liquids, and gases. Oh my. So states of matter are the different ways that matter can exist in our universe. And there are three main states of matter: solids, liquids, and gases. Now, each element and compound has specific properties that determine which state the element will be in, depending on the pressure and temperature of its surroundings. So, for instance, water is a common one that everybody knows. Water is a liquid at room temperature, but if it gets above 212 degrees Fahrenheit, it boils off and becomes water vapor, which is a gas. And if it goes below 32 degrees Fahrenheit, it becomes a solid, becomes ice. So that's an example of the states of matter. Now, this is what all the different states look like. There's a fourth one over here, plasma, which is also a state of matter, but it is not as common, so we don't cover it as often. But the other three are here: solid, liquid, and gas. First, talking about solids. Solids is when a matter is packed together, rigidly together, generally in some sort of repeatable pattern. So as you see in our picture down here, we've got our red dots all in a pattern here. That's a solid. Individual atoms in this form can vibrate, but they can't easily move about because they're stuck in this rigid pattern. Liquids, on the other hand, can flow freely around each other, and that's because there are attractive forces keeping them from separating, but they're not rigidly packed like a solid. So the liquids are always able to assume the shape of its container. So if you pour a liquid into something, it's going to look like the container it's in. Now, as for gases are when molecules and atoms can fly freely in all directions, and that's because they have gained so much energy that they are able to overcome the attractive forces. They can't be kept together like a liquid can. And gases also can fill the container that they're in, but they'll just be more spread out. Now, the fourth thing that I told you about, that fourth state of matter, is plasma. And that one is pretty difficult to achieve. You have to have incredibly high temperatures and incredibly high pressure, like a star. And in this instance, elements would lose their electrons, and then those electrons and nuclei are going to float freely in this mixture, kind of goop. And that's plasma. Now, like I said, all things can shift between states of matter, from solid to liquid, solid to gas, all those different things. I got a bunch of different names for those things on the screen here. Now, this is all changed based on temperature and pressure. So those are the two things that are going to determine what state of matter you're in, what pressure they're under, and what temperature they're under. Now, the last thing we need to talk about is what's called a phase diagram. And a phase diagram just details the conditions needed to change between the states of matter. So as you can see, this is the one for water right here. And you can see that at these pressures and these temperatures, water can be solid, liquid, or a gas. And there's two special points on this phase diagram. The first one is called the triple point, and that's right here. And the triple point is basically where all three phases can exist at once. At this exact pressure and this exact temperature, you can have ice, water, and water vapor at the same time. They would both all coexist at the same time. Now, the critical point, which is up here, is where an element or compound will become plasma. So if you go beyond the critical point, that is when you would have a plasma of water. Thank you so much for watching this episode of Science Terminology. I'm glad you're here to learn, and I can't wait to see you next time. See you later.